Hey guys, welcome to the parallel programming. So, last sessions, if you remember, we have compiled our couple of GPU code, and what we did was like we used the heaps as a compiler, and from the command line we create the output, and we then create an executable, and then we execute it. Okay, and in this execution, we don't have like a proper control of when to like delete the file, generate a new file, and the output file name. So there is a lot of jargons for that. So when it's a single file, it's easy to work with this kind of thing. But if you are going for your parallel programming projects, so it's not a recommended way. So the best case is that we design our make file. So that's what we are going to talk about in this session. So make file. So let's dive into like what it is, and let's see on our playground. So it's much better to understand. So uh, let's take an example. This is like a simple hello world program that we written last time, which will just calling out this kernel, and it will print us like what is the thread and the block ID, whether invoking this hello GPU kernel or explicit of a calling of a kernel. And this is what the makefile look likes. So what we are trying to do here is we are creating what would be the path to the heap. So slash opt slash rockham, this is a path where we will find our heap, and then the heap cc. So basically this is the compiler location. So if you are having a multiple versions and we need to change the compiler path, then it's easy to change when we are using the make. And you can see that we are setting up the GPU architecture. So what we are building, so as you know, so this architecture is a GFX 942. So we will be going with the 942. We can specify what are the sources we want to build. Now here we are specifying only one file. That means only one source will be built, and the objects files. This will create the objects files from the sources from .cpp to .ox function, and we are defining the executable file, which will create this executable file. And eventually what we want to do is like we can add compiler flags and linker flags. So if you see this one at compile time, we are giving a couple of flags, like we are adding the optimization for openmp. We are also adding the GPU architecture which should be used to build this program. And eventually when we come to the executable section, so what's happening? So like you can see, it will build the object first and then it will compile those objects. Okay, and eventually what we are trying to make here do is we have a couple of sections over here. So when you see the test section, it will actually run the executable. So by default, when you do a make of a system, it will not compile your executable program. It will only create till the executable. Let's see. So if I write the make, so as you can see, what it does is it compiles and it generates the executable. So that's two files you are seeing over here. And that's all. That's the default what will happen with the make. Now what happens like if I want to delete and create a new file? So that's where there is a rules of a clean. So basically what we are going to do with like a remove function, it will do with the make clean. And yep, we got it clean. And let's say for example, what if I want to compile as well as a test all together? So there is a make all. So here we are mentioning executable and the test function. So I can do make all. So as you can see over here, it has compiled our program successfully and it has started executing the executable. So this is what we will do with the make file. So it's just a basic overview you can say, but this is a way to manage. So you can manage all the section and all the stuff that you want to do. And it's not like that you can do only one thing. Let's say, for example, you can do this make clean. So everything is clean. And now you can see that you can do a make only. So here we just only have our compile and executable ready. And if I do make test, it will execute. And I can run this make test anytime I want, and it will run it. Isn't it cool? Okay, that's it for this time. So next session, we're going to start with how we'll take the profiler of the same program and what we are going to look up to and how the call stack is going to the hardware systems. Okay, thanks a lot.